Hello ladies and gentlemen, this is Mr. Cunningham, and what we're going to be going over today is we'll be going over lesson 3, which is how to convert between mass, moles, particles, and now we're going to add in liters of gas. So again, there's some bell work there that you can try if you'd like to pause the video just from some previous problems, and again in the bottom right hand corner of that box you should see the answers for those problems. But let's look and go over our objectives and our goal. So sub-objective 1, you should be able to calculate the moles of elements in a compound. Sub-objective 2, be able to use dimensional analysis to convert between liters and other mole amounts, meaning mass, moles, or particles. And also our goal for this is to be able to convert between grams, moles, particles, and liters of a substance. So let's go ahead and get started. So in order to find the moles of elements in a compound, the first thing you need to do is you need to be able to find out how many moles of a compound you have. So let's say that we had 1 mole of CO2. Well, if I had 1 mole of CO2, 1 mole of it contains 1 mole of carbon, but it contains 2 moles of oxygen. So basically, whatever your mole amount is of your substance, you would take that number and multiply it by the subscript of the element that you're trying to find. So since I have 1 mole of carbon, if I do 1 times the subscript of carbon, which is 1, that's how many moles of carbon I have. So 1 mole of CO2 contains 1 mole of carbon, but if I do 1 times 2, that gives me my 2 moles of oxygen. Okay? So if you had something say like 0.5 moles of H2, how many moles of hydrogen do you have? Well, if I had 0.5 moles of H2O, okay, 0.5 moles of water, if I wanted to find the moles of hydrogen, I would just do 0.5 times the subscript of hydrogen in that compound, which is 2. Okay? So how you might kind of draw this or write this in a dimensional analysis way is I know that I have 0.5 moles of H2O. Well, what's my conversion factor? Well, I know that 1 mole of H2O has 2 moles of hydrogen and 1 mole of oxygen. Well, I'm not concerned about the oxygen right now because I want to know how many moles of hydrogen I have. Well, I know that 1 mole of H2O has 2 moles of hydrogen. So that's a conversion factor. 1 mole of H2O equals 2 moles of hydrogen. So because I have moles of H2O here as this unit, I'm going to put my 1 mole of H2O on the bottom and my 2 moles of H on the top. So notice how my moles of H2O and moles of H2O will cancel out. So I would end up doing 0.5 times 2, which would give me my moles of hydrogen, which would be 1 mole. Okay? Fairly simple idea. Basically, you take the moles of the compound that you have, moles of your compound, and you multiply it by the subscript of the element that you're trying to find in that compound. Okay? Now, let's say that we were trying to find atoms of elements in a compound. So what I would do here is I would really do the exact same process, except now I have to do one more step. So after you've calculated the number of moles of an element, you can then calculate the atoms of an element by multiplying by 6.02 times 10 to the 23rd. So in our previous problem, we calculated that we had 1 mole of H. In order to get to the atoms of H, I would then just take my 1 mole and multiply by Avogadro's number, again, which is 6.02 times 10 to the 23rd. So it looks something like this. I know that 1 mole of hydrogen was how many I started with from my last slide, and I know that 1 mole of hydrogen contains 6.02 times 10 to the 23rd atoms of hydrogen, so then I would just do 1 times 6.02 times 10 to the 23rd, which again is the same number. So that would be how many atoms of hydrogen I have. Now obviously we used simple numbers in these calculations. They could be really complicated decimal numbers. They could be 0.63. That doesn't matter. If I had 0.63 moles of hydrogen, I would just do 0.63 times 6.02 times 10 to the 23rd, and I'd get the number of atoms of hydrogen. Okay? Again, my moles of hydrogen would cancel out, leaving me with just atoms, which is how I get this unit. So let's talk about, here's all of the unit factors that we've had so far. First one that we learned was we know that 1 mole is equal to 6.02 times 10 to the 23rd particles. Second one is we know that 1 mole is equal to the molar mass of the substance. Remember, this changes every problem. Anytime you change the compound, molar mass changes. Another one that we're going to add today is that 1 mole is equal to 22.4 liters of gas at STP. Okay? So STP stands for standard temperature and pressure, which means as long as you are at 0 degrees Celsius and 1 atmosphere, that is STP, standard temperature and pressure. Okay, so you'll see this a lot in your problems. We'll talk about gas laws later on in the year, and you'll start to understand more about this. For right now, it's not important that you know what STP is. It's important that you know that 1 mole of gas occupies 22.4 liters when you're at STP, when you're at that condition. So now we have 3 unit factors we can use. We can convert between particles, moles, mass, and then now liters. So here's kind of a new and updated roadmap. Obviously the one on your last notes page just had these 3 circles. Well, now we're adding another one. We're adding volume in liters. So you can convert between volume in liters and moles by using this conversion. 1 mole is equal to 22.4 liters, and that's only when it's a gas, so keep that in mind. Okay, so you should have that mole map on your page. This will be, again, very helpful for you in order to convert between units. So let's look at some problems. Here's our first problem. It says a sample of methane, which is CH4, occupies 4.5 liters at STP. How many moles of methane are present? Well, we want moles, we have volume. So let's look at our mole map. We want moles, we have volume. So in order to convert between volume in liters and moles, I'm going to use this conversion. So I was given 4.5 liters of CH4. Well, I know that 22.4 liters is equal to 1 mole when it's at STP. So I need to decide, how do I set up my dimensional analysis? Well, because this is in liters and this is in liters, I'm going to put my 22.4 liters on the bottom and my 1 mole on top. Then these units here would cancel, so I would only be left with my 1 mole of CH4. So I'd have 4.5 divided by 22.4. That would give me my numerical value, 0.201. Then the only unit that would be left is my moles of CH4. Next one is a mass and volume calculation. So let's say, what is the mass of 3.36 liters of ozone gas, which is O3, at STP? Well, let's go back, look at our mole map here. Again, it asked us for mass and it gave us liters. Asked for mass, gave us liters. So we need to go here, and it gave us this, which means I need to go from volume in liters to moles, then from moles to grams. So how I would do that is I would start with my 3.36. Looks like I forgot to have the PowerPoint show this in stages, but I'd start with my 3.36 liters because that's what was given. So because this was in liters, I would use my 22.4 liters over 1 mole here. Then those units would cancel. Then I would use, for my next unit conversion, remember now I would be in moles. If I stopped here at this calculation, I would be in moles. But I need to go to mass, or grams. So then I would use my next conversion, which is 1 mole is equal to the molar mass of my compound. Well, it was O3, so because I have moles here, I want to put my moles here, which puts my molar mass on top of this dimensional analysis. So I do my 48, which is oxygen, which is 16 times 3 is 48. So then my math here would just be 3.36 divided by 22.4 times 48. That gives me 7.2. But then to find my unit, I just look at the only one that cancels out. Oops, I'm sorry. This line should be down here. So really this should be in grams. So this yellow or green line here, excuse me, is in the wrong spot. This should be here, green line should be here, and then I should have grams of O3 right here as my final unit. Okay? Then our last calculation, how many moles of hydrogen gas, or H2, occupy 0.5 liters at STP? So we want molecules. It asked us for molecules, and it gave us liters. So in order to convert there, gave us liters, asked for particles. So I'm going to convert from volume to moles, then from moles to particles, using these two conversion factors. So I would start with my 0.5 liters. Then, because this unit is in liters, I would put my 22.4 liters on the bottom and my 1 mole of hydrogen on top. My liters are going to cancel. Then, if I stopped here, I would be in moles, but I don't want moles. I wanted molecules. So now I will use my next conversion, which is 1 mole of H2, I know, contains 6.02 times 10 to the 23rd molecules of hydrogen. So I would use my 6.02 times 10 to the 23rd molecules on top. I'd put my 1 mole of hydrogen here on the bottom, because the 1 mole of hydrogen is also here, which cancels out those units and just leaves me with molecules, which is the unit that it asked me for. Then to do my math, I would just do 0.5 divided by 22.4. Then I'd multiply in parentheses by 6.02 times 10 to the 23rd, and I would get that I have 1.34 times 10 to the 22nd molecules of hydrogen. So again, the new conversion that we have is just the 1 mole is equal to 22.4 liters. Using your mole map and getting used to using that and kind of internalizing it is something that's going to be really important. So hopefully you can complete the objectives and be able to do the objectives and goals that we talked about. Again, you should be able to calculate the moles of elements in a compound. You should be able to use dimensional analysis to convert between liters and moles. And you should also, now our overall goal is you should be able to now convert between those 4 units. You should be able to convert between liters, moles, particles, and mass of a substance. So if you have any questions, make sure you let me know. Thank you for watching.